Okay, so let's begin. An operating system is system software that manages computer hardware and software resources and provides common services for computer programs. Arranging a computer system into layers, as first approximation, we have 4 abstract layers. The top layer corresponds to users who launch or terminate applications at will. For some systems discussed later, internal system processes can be initiated in response to external events. For instance, in the case of a self-driving car, events on the road will trigger certain applications to handle that information that is coming from sensors and respond accordingly. The next layer represents applications. Applications provide useful functionalities such as text editing, playing music, or sending messages in a chatting program. The third layer is the operating system itself. The operating system provides access to the memory and processor via an application programmable interface, a short API. The bottom layer is hardware that includes input and output devices, primary and secondary memory and processor. But without the operating system, hardware is pretty useless. Okay, so from the perspective of provided functionalities and application fields, operating systems are categorized as follows. Single and multitasks, single or multi-users, simultaneous access, distributed systems or systems that run on a single machine, and embedded or real-time systems. There are 2 types of real-time systems: hard real-time and soft real-time operating systems. In a single task operating system, only one task at a time can be executed. The first generation of operating systems were single task. Among relatively recent operating systems, Microsoft DOS was a single task operating system. Multitasking operating systems allow more than one program to get executed at the same time. Well, it's done via sharing processors times and computer's memory. Each application gets its own slot to complete some part of the task. And by switching quickly between apps and appearance of a parallel, execution is created. In modern computers, the applications are indeed executed in parallel due to multi-core processors and hence internal hardware parallelism. Most of the modern operating systems are multitasking. Imagine how boring it used to be when a user is editing a file and are not able to listen to music or chat in the messenger or do some other stuff at the same time. But it's quite amusing, maybe not for the users of iOS devices, but the first few generations of iOS, particularly iOS 1, 2, 3, 3.2, were single task operating systems. Only starting from iOS 4, released in June 2010, Apple added multitasking. So just recent examples, you can see single task operating system is still quite popular. In terms of single or multi-user systems, a single user operating system allows only one user to simultaneously operate the computer. Windows 95 is an example of a single user operating system. On the other hand, multi-user operating system allows several users simultaneously utilize computer resources. Such operating systems have an additional responsibility compared to a single user operating system. Because a multi-user operating system, the system should monitor and control the demand for resources required by or requested by application executed from different sessions, and hence make every session gets a fair amount of, make sure that every session gets a fair amount of processor time and memory. Consequently, preventing the situations when one of the users occupy all the resources and the whole system can halt in that case. The next one is distributed operating systems. They play actually a key role in cloud computing and big data analysis. This type of operating system abstract hardware and hardware like processor and memory that are physically located on different machines. Say in here, machine A, machine B, machine C. Each of them has its own memory, its own processor, its own physical resources. But operating system make them appear to application as if there was only one machine. Distributed operating systems are executed on clusters of computers that are connected through a network. Hence, operating system is responsible for distributing jobs to different processors and computers efficiently, and usually it's done again through a network, and every machine is called a network node. An OpenVMS cluster, that is a successor of VMS operating system developed by DEC, is a good example of a distributed operating system. The OpenVMS cluster acts as a single virtual system, even though it is made up of many distributed systems. Embedded operating systems are specifically designed to be and optimized for a given hardware. They're designed to be lightweight, to use less memory, and operate on less powerful processors. These physical constraints are often a result of the economic requirements imposed on the devices. So it's frequently they should be inexpensive, small, and consume less energy. Some examples of embedded devices include banking ATM machines, car control systems, and air conditioning systems. To achieve better performance, most embedded systems are written in either assembler or C language. So we'll talk about assembler and C language in next lectures, but for now you can think about assembler as a language that is as close as you can get to hardware. So it's very efficient. There is no overhead there. To achieve better performance, operating systems has to be implemented in such kind of low-level languages. Well, moreover, the installation images of embedded systems are usually come with the application that will be running on the system. For instance, a temperature controller is in an air conditioner. So operating system, embedded operating system will be coming with the program that is pre-installed in the system. So some examples of such operating systems are embedded Linux, QNX, and Windows Mobile that is now succeeded by Windows Phone, and which is a family of operating systems for Microsoft smartphones. And a side note about QNX. In 2010, BlackBerry, a multinational wireless communication software and hardware company, acquired QNX, and they used the operating system QNX as an OS for their smartphones. So you must probably heard about this Canadian phone manufacturing company, BlackBerry. It used to be called Research in Motion, RIM. Real-time operating systems are a special class of operating systems that are designed to control industrial systems, machinery, and scientific equipment. These operating systems are also often embedded. Let's take a look at a couple of examples. Controlling a nuclear reactor or a Mars rover requires precise timing. That is where real-time operating systems come into play. A real-time operating system focuses on strict resource management, where the goal is to guarantee a system response in a given time interval. The intervals could be just milliseconds long or could be measured in hours. No matter how long or short the interval is, the system has to respond within this interval. If the system missed the deadline once, in other words, responded after a predefined interval, it is considered as the system failed. Such systems are called hard real-time operating systems. In soft real-time operating systems, it is allowed to miss a deadline time to time, but on the average, the system has to respond on time. And in case if deadline is missed, the response is still useful. So in that case, soft real-time operating systems are used. Some example of real-time operating systems are QNX, as mentioned earlier. It's embedded and it's a real-time. Windows CE stands for compact embedded, and VxWorks. The latter one is used in the Asimo robot and the Mars Science Laboratory Curiosity rover. So you can see this selfie of the robot that made it itself on Mars. Recently, by the way, with the spread of IoT devices or the Internet of Things devices, embedded real-time operating systems are in demand, and lots of innovation happening in this field. Okay, so let's now move to the history of operating system, how they evolved. So computers of the first generation did not have operating systems. Programs were stored on punched paper cards or paper tapes. Computers could only execute one program at a time. These were computers used by large organizations for bulk processing. In the late 50s, many features of modern operating systems were introduced. Such functionality is batch processing, when a list of programs is stacked up for automatic processing, and they are processed one by one. Or multitasking were also developed at that time. In the beginning of the 60s, IBM had been working on a new mainframe computer, IBM System 360. Together with the mainframe, IBM supplied the OS 360 operating system. The OS 360 had a number of novelties. For instance, it kept track of all resources being in use, including primary and secondary memory. The first version of that operating system was developed in assembly language, just like the all previous one before it. The OS 360 was the first operating system developed with the purpose to run on different models of the same product line. So this was something crucial, because before, operating systems were only developed for a specific particular computer. This time, IBM developed an OS that could actually be running on different computers, but that belonged to the same product line. Well, at about the same time, General Electric, along with MIT and the Bell Labs, began working on multiplexed information and computing service, or Multics for short. The operating system originally was designed for General Electric's 645. This is a mainframe, or series of mainframes. To promote the system, it was provided as a campus-wide information service at MIT. Multics introduced many key and new ideas that are used till these days. One idea that was conceived in the development of Multics was dynamic linking. Dynamic linking allowed to make programs smaller, and it was because it was smaller. Dynamic linking allowed to make programs smaller, as many programs shared the same functionality and thus could be stored in the memory and shared across programs. This shared code is called dynamic link library. Another important novel concept was ring security, privilege levels, which is a common feature of modern operating systems. For example, Linux and Windows are operating with two privilege levels, named supervisor and user modes. Despite many innovative ideas, Multics eventually lost its popularity. In 1970, Honeywell bought computer division of General Electric, and supplied their own computers with Multics. However, Laboratory for Computer Science Research at MIT stopped working on Multics in the late 70s. Bell Labs ended its support in 1985. One of the leading developers of Multics, Ken Thompson, described Multics as being over-designed, overbuilt, and over everything. The system apparently had demands for resources. Hence, he, Dennis Ritchie, Brian Kenihan, and Rod Kennedy, while working at the time at Bell Labs, decided to develop their own operating system. That would take the best of Multics, but at the same time run on less expensive machine and be more resource efficient. The operating system was named Uniplex Information and Computing Service, or Unix for short. But later, this CS at the end were replaced with X. So it sounded as the same as before, Unix, but spelled a bit more elegantly. Originally, the operating system was developed in assembly language for the PDP-7 that Ken found rarely used within the Bell Labs. And later the system was ported to PDP-11, where text editor was added and some other software. The software was written in assembly language, making it hard to port to other hardware platforms. So Dennis Ritchie began working on a new programming language that could have replaced PDP-11 assembly language, at least in Unix development. By 1973, the largest part of Unix, including the kernel, was rewritten in C, and that was developed by Dennis. And Unix was the first operating system developed not in assembly language. So in this picture, you can see Ken Thompson typing something programming, and Dennis Ritchie standing by his side. And this is a PDP-7, the first machine that was used for Unix development. Okay, so now let's talk about how Unix became popular, and that caused some troubles, because in later years, many organizations started working on Linux and developing their own versions of Unix. For example, Microsoft developed their own version of Unix that's called Xenix. In 1977, John Lyons of the University of New South Wales in Sydney, Australia, wrote a commentary on the Unix source code, explaining line by line what it meant. That sparked interest among professors teaching courses on operating systems. In 1977, Computer System Research Group of the University of California, Berkeley, released their own Unix system named Berkeley Software Distribution that laid foundation for many subsequent versions of Unix. The first version of BSD, although, was more of a modification of the original Unix, because that time Ken Thompson took a sabbatical and went for a year to Berkeley to deploy Unix operating system. And that's where many students learned from him too, and they developed a new version, an alternative version of Unix. Well, to standardize different Unix implementations, Institute of Electrical and Electronics Engineers proposed an open operating system standard, now known as Portable Operating System Interface Exchange, abbreviated as POSIX. So many modern operating systems are either certified as POSIX or de facto POSIX. For example, Linux has never been certified as POSIX, although de facto it's a POSIX system. Well, thanks to this standard, different versions of Unix continue to be compatible. Code written for one POSIX system can be recompiled for another without, or at most, very minor changes. Compiled and executed. Some of the well-known modern POSIX operating systems is Apple OS X, that is descendant of BSD, it's right here. Yeah, so one of the reasons why many operating systems that are used until this day as Mac OS X and FreeBSD are popular is because they are descendants of BSD. And BSD already had network support at that time when it was only introduced. Particularly, TCP IP stack was directly embedded into the kernel. So that's contributed to the popularity of BSD. And modern operating systems such as Solaris and HP UX from Hewlett-Packard are all descendants of Unix. Well, the descendants of Unix are termed as Unix-like systems, and the most popular POSIX systems, as I said, Apple OS X and Linux. So here, graphical user's interface is shown for OS X and for one of the distributions of Linux, Ubuntu, is Unity, shown here. Well, until 1984, AT&T, which division was Bell Labs, was prohibited from turning Unix into a product due to antitrust case that was filed in 1974 by the Department of Justice. However, in 1984, AT&T divested itself of its local exchange companies, and the Bell system, as it was known, ceased to exist. From that moment, Unix legally could have been commercialized, and it was. So the new commercial Unix license was not favorable for universities. So people at academia started looking for alternative operating system. That is when Richard Stallman at MIT founded the GNU project. That was a mass collaboration project aimed at development of free software. GNU is a recursive name. That stands for GNU is not Unix. By June 1987, the project had already portable optimizing C compiler, GCC, that stands for GNU C compiler, and editor, and also various Unix utilities. The only part that was missing is operating system. One candidate that got close to the role of free and open source operating system was Minix. That's actually stood for Mini Unix. The OS was designed for educational purpose by Professor Andrew Tannenbaum. Although being open source, it was not free. A small price of $68 was charged. Moreover, there were license restrictions on the use of the operating system outside of academia. Meanwhile, while attending the University of Helsinki, Linus Torvalds became curious about operating systems and frustrated with the licensing of Minix. So he began to work on his own operating system, which eventually became the Linux kernel. So here's, you can see him on the picture. Well, on August 25th, 1991, Linus, at the age of 21, made an announcement. He announced his system to the news group. And here's what he said. Hey everybody, out there using Minix, I'm doing a free operating system, just a hobby, won't be big and professional like GNU, for 386 and 486 AT clones. So these were Intel processors, quite powerful at the time. And this has been brewing since April and is starting to get ready. I'd like any feedback on things people like, dislike, and Minix, as my operating system resembles it to somewhat. So same physical layout of the file system due to practical reasons, among other things. I've currently ported Bash and GCC. So Bash, we will talk about this a little bit later. And things seem to work. So this implies that I'll get something practical within a few months. And I'd like to know what features most people would want. Any suggestions are welcome, but I won't promise I will implement them. It's interesting how he states that it's not going to be professional like GNU, and it's just a hobby. Well, Andrew Tenenbaum, the professor Andrew Tenenbaum that developed Minix, and you can see that Linus based his kernel, his operating system on Minix, was quite skeptical towards Linux. As Linux stated in his announcement that Linux initially was designed for Intel processors only for these two processors. It also had a heavy monolith kernel, making the OS less flexible for further extensions and if someone wanted to port it. So nevertheless, as we know now, Linux has been ported to a vast majority of platforms, from small embedded computers to massive clusters of servers. Today, it's the most popular operating system for servers. Well, another branch of operating systems that was developed independently of Unix originated from Digital Equipment Corporation in 1975. So the same company that was pioneering many innovations at that time. It was a completely new operating system named VMS and developed for a new series of mainframes, DAC VAX, that stands for Virtual Address Extension. VX in turn was viewed as an extension of PDP-11, the famous mainframe that first version of Unix was officially released for. Later in 1991, the OS was renamed to OpenVMS to indicate that it is a POSIX system and compatible to Unix. And yeah, but unfortunately, the source codes were sold separately, so it was not really open. I mean, companies could purchase the source code, but they were not able to redistribute it. OpenVMS was a multi-user, multi-process operating system designed for batch processing and use in time sharing. One of the VMS architects was Dave Cutler. Bill Gates, the Microsoft founder, recruited Cutler in 1998 to work on a desktop and a server operating system that should have been scalable, secure, and portable. The first release of this new operating system that Dave Cutler was working on was in 1993, and it was Windows NT 3.1. NT stands for New Technology. Windows NT was not the first operating system developed by Microsoft. As was discussed earlier, success of Microsoft is associated with disk operating system, DOS for short. In 1981, Microsoft purchased 86-DOS operating system, initially known as QDOS for Quick and Dirty Operating System, and continued developing it as its own Microsoft product. DOS was licensed to IBM as PC-DOS. In parallel, Microsoft was developing MS-DOS that eventually became a separate product with different capabilities. MS-DOS was developed for Intel 8086, and thus subsequent Intel processors of 86 family were able to run Microsoft DOS. And well, yeah, Microsoft DOS had a command line interface, and later on a third-party file manager using pseudo graphics was developed that actually significantly simplified operations with files. To keep up with competitors, particularly with Apple, that already had graphical user interface, in late 1983, Microsoft released a graphical user interface as an extension of MS-DOS. And in 1985, the first version of Windows was released. That was a standalone application. It was not still an operating system. It was an application that was executed from the command line. The last version of Windows as a standalone app was 3.11 and released in 1993. In 1995, Microsoft replaced MS-DOS with Windows 1995, right? Windows 95. That was a full functional operating system booting directly to GUI. In a few years, Windows 98 and Millennium Edition are followed. Where Millennium Edition, you probably heard about this operating system, was abbreviated as ME. So the Windows ME was the last operating system in this branch before discontinuing working on it. So since Windows XP, NT branch had become the foundation for further Microsoft operating systems. So here you can see how interface of Microsoft products, Microsoft operating systems evolved. So MS-DOS just had a command line interface and nothing more than that. Later on, end of 80s, these file managers were developed by third-party companies. So in this is a Norton Commander. I remember using this. It was very comfortable, way more comfortable than this one, to copy files, to edit files, to execute programs. Then Windows was introduced. This was a wrapper for MS-DOS. It was, as I said, standalone application, but it was something that looked very similar to Apple desktop. That's why Apple sued Windows. And finally, in 1995, Windows 95 was introduced. It was something different. So now it didn't look like Apple, and luckily for Windows, there were, as far as I know, no lawsuits filed by Apple. Okay, so to overview this lecture and to check if you remember and understand what has been in the lecture, please try to answer these questions and yeah, for your own practice.